Wait a second. Huh. I feel like I got it wrong again. I should be committing on the second. I think I forgot to commit on one day. Shoot. Alright. Morning, everyone. It's February the 2nd. Yeah, I think I forgot on the commit. I missed one day. I said 31, but actually this will be yesterday. I forgot. Alright, so let's do this. And I think I have some thought. About this. I'm going to try. Alright, sequential digits. An integer has sequential digits if and only if each digit in a number is one more than the previous digit. Return a sorted list of all the integers in the range, low to high inclusive, that have sequential digits. Okay. Sequential digits. 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, and 7, 8, 9, 10 I cannot do. And it has to be smaller. Okay, so the lower bound, there's only so many you can do, right? So given the lower bound and given a higher bound. So the lower bound will give you so the most is this, so we can probably write out everything, right? We can probably write out everything. And if we write out everything, it's depending on the digits. And for each one, we can binary search, or we could just do a sequential search because it's not going to be slow at all. It'll be pretty fast. Huh. What you're saying is we're gonna do something like this, right? 2 digits at least. So for 2 digits, it's gonna be 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, right? 3 digit, 1, 2, 3, 2, 3. Hey, good morning. I was a bit late today. 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8, and 8, 7, 8, 9, right? 3 digits. Yeah, maybe we can write it out, all of them. I mean, we can program this, right, to write it out. We can do a string. We just add. No, we don't do. We can just times 10 plus a new one, and then divided by mod 1000. Mod 1000. Yeah. What question do you have? 1, 2, 3, 4. But anyway, and then 5 digits, 6 digits. Okay, so we can build this, and then giving me a lower bound, I can search to know where it's going to be. Wait, is it inclusive or not inclusive? I think it's inclusive. Okay, so we can binary search, so we can get this, and then go to the high, depending on the number of digits. Then we jump, and get to the high, and then we get the high. Yeah, I think this will work. How do I learn new tech stacks? Tutorials. Tutorials. I mean, the last time I learned something new tech stack was to learn how to write APIs using Fast API. That was the last kind of a major learning I did. And yeah, read online, read tutorials, documentations. And at that time, I didn't like what was available online. Didn't solve all my problems. So I have to dig like somewhere here and there. Oh yeah, it's actually Fast API, and to deploy Fast API as a microservice on Lambda. So that one took a lot of learning, but after many tutorials and after many Stack Overflow, was able to put together a working example. And then I wrote an article about it. I think that also helps. You learn something, and then once you finish learning, you think you reach a state that you feel happy about it, you write it. You write everything down. You provide an example so other people can follow. That helps me learning as well. And yeah, but since then I haven't done any serious learning. I can count NeoVim. That's also a learning. But on NeoVim, definitely not on the level of writing some stuff. For NeoVim, watching videos was actually more, because there are a couple of guys who are really good at NeoVim, and they're promoting the use of NeoVim. So just watch videos. There's a guy, the Primogen, pretty funny guy, and just watch his videos on NeoVim. And TJ, I think he wrote the Lazy Vim. So just watch their videos and then try it out yourself. The next thing I want to learn, that's always on the horizon, is Rust. Is Rust. Always wanted to get on that bandwagon. Rust, Go, for a new language, definitely, you learn it by, I have to learn Lua to configure my NeoVim. But Lua is relatively easy language. It's interpreted. Nothing too special about Lua. There's a little bit quirky things about it, but you do a little bit tutorial, you're good enough to start configuring the Vim. Rust or Go, they're different, and but Rust has very good documentation. So I'm just follow the documentation. And since I do LeetCode, and LeetCode has a Rust. Look at this. LeetCode has Rust and LeetCode has Go. So basically, let's call it when I start the journey of Rust, I'll definitely do LeetCode in Rust, because I absolutely do not like Java. I do not like Java, but it's an important language, right? So I kind of practice it still. But once I start Rust, I will do it here in Rust. If I start Go in here, so solving these problems, it's kind of getting used to the syntax of the new language. Seriously, if they have Lua, I'll do in Lua, but they don't have Lua here. But for really understanding language, you have to use for projects. For Rust, I have some plan to write some command line tools. Okay, so probably calling the tools a little bit too much. It's just some easy stuff to do on command line. I'll do it in Python first, just kind of to see how the mechanics work, and then after that, I'll translate everything into Rust. So that's kind of the plan, to learn Rust. But other than that, just tutorials, documentations. That's all you can do. As for jobs, when I was applying for jobs, it's just everything online. Indeed, ZipRecruiter, LinkedIn, whatever I can find a new position posted that I think might fit, my skill set, I just apply for it. And then I remember applying for almost 200 jobs in the last round of application in 2 months. Yeah, a month, 2 months ish. range. So try to average about 10 jobs every day. It's a numbers game. It is definitely a numbers game. I mean, I got only one response applying for so many, just one response. But it's a numbers game. You put your number there, and things will come back. It's actually a good period of time for me to learn new stuff. I did all the learning on Fast API and how to deploy Fast API on Lambda during that time, because I have it just doesn't take that long to apply for 10 jobs every day. And after application, you just have free time and you learn new things. You try to put on your resume, put on your write some articles, something to show for. Get in the habit, right? Because for me, just doing LeetCode is a habit of trying to be a better self every day. Even solving the problem I solved before, like this problem, right? I solved it before, but you forget, and your mind will regress, so you solve it again, and you try to just keep pushing yourself. It's a hard journey, right? It's just pushing the rock uphill. If you stop pushing, you'll always go back down. And for me to survive in this industry, you just have to keep pushing every day. In your job, in regular life. All right. Anyway, I think we have a strategy, and let's just Java this. I am not in favor of Java on this thing. Just thinking about doing the binary search just give me the uncomfortable feeling. But anyway, so first I said we are going to build the library of all the numbers, and we are returning a list of integers. Okay, that's at least not that bad. So I need a library. Okay, what's the library going to be? Library is going to be a list, right, of integers. So a list of integers. Right, that's the library is going to be. I'll call it lib, right? We do that, and then what we need to do is create this thing. Oh, using Q. I don't remember using Q. Maybe that's a better idea. Anyway, I'm gonna use my idea. So what we're gonna do is we'll call it D. We're gonna start with 2 digits. Okay. What's gonna be the and? And is gonna be 9 digits. So we're gonna do 9 digits. Okay. And then what? For each one. Oh, D is 2. I probably need to put 2 dummies in it at the beginning. Oh no, is it add? Push? Is add. New list integer. Oh, that is not what I want. Should be new array list, right? Oh, it's so awkward. Array list. And then lib dot add array list. Okay, so these 2, and then we can just push a new one in. Okay, so we say lib dot add new array list. Okay. No, actually we can do this. We say a list integer current equal to new array list. Okay, and then we'll add it at the end. Then we're just gonna go through the whole thing. So 2 digits, we're gonna have a start. Okay, so we have a start. We push the start in. Okay, we push the start in, and we say current dot append add. What is the start? Huh. How do we do the start? You know it's 1, 2, right? 1, 2. I mean, can we compute 1, 2? I can do. Yeah, I guess we can compute the start. Right? We can compute the start times 10. Okay, compute the start. So let's say integer, a current list. Okay, let's call current list. Okay, current list, and current num, and we're gonna start from as a 0, right? And then we say for int, I call it I equal to 1, and then I small equal to d. That's the max we can go, I plus plus. And then what we're gonna do is we say current num equals current num times 10 plus this I. Right, so we get start with 0, so it will be 1, and then go again, it will be 12. Right, so that's the current num. And then, oh, I guess this one is int. Right, and then we can say, we can start putting the current number into it. Like, how many do we go? I think it depends on how, I mean, if it's 2-digit, right? If it's 2-digit, we'll have how many? 1, 2, we have 8. So 2-digit we have 8, 3-digit we have 7. So it's 9, right? Minus 9 minus 2 plus 1. 9 minus 3 plus 1. 1, 2, 3. Okay, so we're gonna do that. We say for, let's call j equal to 1, and then j smaller equal to d, no, 9 minus d, right, plus 1, j plus plus. I'm thinking, while I'm doing this, I could just go through this thing directly, right? I mean, why do I do this? Oh, you do this because it will be easier, because this number can be a, real number that you will have, but it probably won't be, right? You just need to figure out which one is the start. Huh. Maybe I can do it directly. Like, seriously, maybe I can do it directly. I don't need a library. All I need to do is go start from this, and then if it's not within, I just skip it, right? I just skip it because it's hard. It won't be that many laying around, right? It won't be that many laying around. So okay, I don't need this. I think I can just go with list integer res, right? A new array list. I can do this directly, and I don't need this. The digit is how many digits this one has, right? So how do you compute the number of digits? You do a log, right? You do a log. So we can do math.log, it should be log 10, right? Low. This will give you the number of digits when you take the integer of this. So it should be math.floor, right? Wait, does floor return an integer? Good question. I actually don't know. Does floor return an integer? No. Okay, how to take the integer part? So Java take integer from a double. Oh, I just cast it. Oh, I can do this. Floor it and then do int. Okay. So this is the starting number of digits, and this will be the and. So floor math.log 10 high. Right. So these are digits. So the current is this. So it'll start from 1 to this. I get this. Okay. And then this is, what is this? This is the total number, right? The total number will go through. Okay. So now what we do is simply given every single one, right? Give every single one. I will check if the current is, okay, we say if current number is larger or equal to low and current number is smaller or equal to high, right? If this is good, then we say res.add current number. Okay. If not, if it is not, then else then we just break. Else we break. Right, if we have something, no. If it's smaller to low, if it's yeah, hold a second. We say if current is larger than high, right? That is too big. That we just break. Right, that we just break. Otherwise, if it's larger than this, we'll add. Okay. Otherwise it's smaller than low, right? If it's smaller than low, we just keep going, but we need to produce the next one, right? How do we produce the next one? So the next one, we can say current number shall equal to, the next one is current number times, because we need to times this, add this, and then do this. So times what? Times the current digit. Oh, power, 10 to the power. How do I do 10 to the power? Java, 10 to the power of. Oh, I could, oh yeah, I could have just do that, right? We could just do int power of 10. Okay, so 10 to the 1, 2, 3, 4, 1, 2, 3, 4, 5. Probably there's a way. Oh my goodness. Oh my goodness. Yeah. That is a good way. That is a good way. Yeah, and then this is not int, this is int this. Right, we're gonna do new int, and then we need to initialize it, so we use this. Right, and then we say it's 10 to the 5, 10 to the 6, 10 to the 7, 10 to the 8, 10 to the 9. Alright. So 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. I think that's too much. 6 should be 5 zeros. 7. 10 to the 7. 10 to the 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the power. And then we can do times power of 10. Okay. we can do power of 10. Give me the current digit. D is the current digit. Right? D is the current digit. Can do so 1. That we do that. Current digit. Do we need to do current digit times? Oh no! I just need to times 10. I just need to times 10. No. I just need to times 10. The current times 10 plus the current number mod 10 and then plus 1. Right, that's to add the last one. And then we'll add that and then we will mod. This is where mod comes in. Right, this is where mod comes in. So we're gonna mod power of 10 of D. Right? Does that make sense? Does that make sense? So if it's 3 digits, we times 10 is 4 digits, right? And then we mod 100. So we get, yeah. So that's the next one. So we go back up. If it's not good, so we keep going until we're good. So we need to jump out. And then we don't need this, right? And then at the end, we just return rest. Okay, let's take a look. See if this one works. Okay, let's see if this one works. Almost works. First one doesn't work. I have no clue why. I got an empty that's weird. Probably is this one right? Okay, I'm a little suspicious on this one. But it should be, because the second one, no, it probably is not right. Sys.println out. System.out, right? .print line. I just want to see. Oh, I could have just debugged it. 2. That is not right. That's 2. Oh, yes, it is 2. Dear me. It should be plus 1. Number of digits. It should also be plus 1. Number of digits. There we go. Okay. Confidence. I think this one will be right. So I'm gonna just put it in there. 1291. Just iterate right through all the sequential digit numbers from the lower bound of the number of digits until the higher bound of the number of digits. Well, we can simply iterate through them all, because you okay? Because the total number of qualified numbers is not that many. Okay, so I don't even know what to call this. I just submit it. was in Python in the past, and now we're in Java. So that's pretty good, right? That's pretty good. I wonder if I had a, better solution in the past. It's for the second. Okay. Let's take a look at the previous. I have two previous solutions on this. Oh yeah, in Python you can do that. Yeah, you can do that. It's pretty simple. It's pretty simple. Yeah, it's pretty simple. I guess maybe I can do this. Oh, it's a queue. A queue solution. Wow, queue. Pop left. Always times 10 plus this plus 1. Yeah. Go back up. Go back up. Go back up. And if the last digit is 9, we don't do this. Yeah, what if the last digit is 9? Pop left, and then we push something on the right. And then we check. Keep going until we hit a point where it was ending, like say 8, 9, right? Then we will just pop and come back in. Wait a second. How do we go to the next digit? The next length? Oh, this one directly goes through it. Oh, we start from 1 to 9, right? And we'll add, this is at the next, oh, this is at the next level. So 1 to 9, next one will be times 10, right? It's 11. No, it's 10 plus 11, so it'll be 11. No, it'll be 12, right? 2 comes in, will be 23. 3 comes in, will be 34. All the way to 8 comes in, will be 89. 9 comes in, don't do anything. And then 12 comes in, will be, oh, I see now. I see now. Yeah, this is Q. This is Q. Okay, let's write the Q solution then. Yeah, so the reason was I was thinking about how to get the next value, right? I was thinking about how to get, let's say, 2, 3, 4 from 1 to 3. So I have like this one. This is how I'm thinking to get the next value. But it's much easier to get the next value from 23 to 234. And from 234 to get 2, 3, 4, 5. Because we just need this one times 10 plus the last one plus 1. Now you just add it together. And then if we go as a queue, each time we hit some value, we can put its next, like vertically, its next towards the end. Beautiful. The queue solution is beautiful. All right, let's do the queue. Let's do the queue. Okay, so this is the queue solution. It is possible. The key to realize that a queue is good, right, for this problem is that we produce 2, 3, 4 right, from 2, 3 instead of 1, 2, 3. Yeah, I hope I understand how this one goes. But anyway, Q. what is the q? Okay, we have q integer, right? So we can call q new q array deck. Array deck. I think it's array deck. Okay. Oh, I mean, if it's array deck, we probably just call it deck, right? Okay. And then need to put something in it. Well, we can use for I equal to 1, I small equal to 9, I plus plus, and then, I need to define I, right? So we can say int, and then we do q dot add I. Okay, so q is defined, and then we just say while q is not empty, right? Q dot is empty, is not empty. If q is not empty, then we need also a result. So we say list integer res equals to new array list. Okay, and then when q is not empty, we say int current is equal to q dot pop. Oh shoot! Poll first. Poll. I think poll will be good. Right? Poll is on the left hand side, and then we say if current is larger equal to low and current is smaller equal to high. Right? If that is the case, then we say res.add current. Good. If it's so current mod 10, right? If it's smaller than 9 exactly, then we do q dot add. So the next one, so we are going from 23 to 234, right? So it's current times 10 plus current mod 10, get the last one, plus 1. Right? And then we do that, and then we'll return res. Oh, this is such a good solution. 19K. Can run this. Yep, it's the Q. It is the Q. Well, that's all right. It's the same. All right, so that one is that. All right, coming back to this. So the idea that I have for this is like this. Okay, so it's different. So yesterday I got stuck because I feel like all the solutions are O(n) squared. But here's the new idea. Here's the new idea. Okay, so again, let's write this one out. Right, we have C, A, B, A, C. So the ideal is recursion, right? We do DFS. So we start from here. Okay, so basically we say we have a root. We have a left, we have a right. If I can get, okay, if I can get a counter on the left hand side and a counter on the right hand side of all the paths, right, of all the paths that starts from my left node or my right child. So it's all the paths starting from here. And it can be, a length of 1, length of 2, length of 3. It can be any length. But we're going to get a counter with their bit mask. Okay, with their bit mask. So I have a counter of all their bit mask on the left hand side. So starting from here, right? All of them. Then, oh, it doesn't work again. It's still because I have to, because how do I update this bit mask counter when the root is incorporated? Oh my God, you're kidding me. You're kidding. I have to go through this whole thing, right? I have to go through this whole thing. And this whole thing might be long. Actually, how big is this whole thing? Well, it's 26, right? We have 26 positions. So the whole thing is as long as the maximum on the whole thing is 2 to the 26. How much is 2 to the 26? That's way too big. That's way too big. That's what, like 67 billion. Right? That's 67 billion. But I don't know. Will it be that big? All the paths? I mean, it could be big. I can see it being big. But that we can give it a shot. Okay? We can give it a shot. So like each one, I got all the bit mask. Yes, I got all the bit mask. And then for me, I got all the bit masks on here as well, right? And then I can check if any one of these I can make a palindrome just on this side by just check if it exists, like this one, because we need something. Oh, that actually is also, we have to do every single one. We do have to do every single one. Exclusive or every single one. So we get a new one. So we get a new counter with root and left. Right, we get a new counter. Right? And then how about on the other side? Okay, on the other side I get it as well. Oh no, this doesn't work. This does not work. Yeah, it's not like the exclusive or. I mean, it is. Technically it is. Technically it is, because we can have a set of numbers. 26, 27 numbers, right? So I do exclusive or every single one to see if it's inside the 26 numbers. If it is, that's a count, okay? So once I'm done here, I need to do on this side as well, every single one. Oh, see that, because at the end, what I need is all of them, right? To start from here, I need all of them. See, that is a problem. That is the problem. But if it's just a path, if it's just a total path, right? We have like A, B, C, D. That's like one path, and then another one, and another one, another one. So we have all the paths, and each stop is a node in between, and then that is not that big, because that's depending on the total number of leaves we have. So we basically have these strings, and then on the right hand side I have like all the strings on the right hand side. And now I have the root, right? We have the root path. We have this new string here. I can add to them. What if you add to them and then you add to here? You have to loop through them again. You're kidding me. You have to loop through them again. That is not. That is still O(n) squared. From and back, we're always O(n). All right, I'm gonna look at the hints. I have no idea. Okay, DP. I know bit manipulation. I know it's gonna be bit mask. I know it's DFS. Yeah, I actually don't know. It's DP. It says DP. Did you think about DP on this? Honestly, I did not think about DP on this. Maybe that is the missing piece. Maybe I don't have to always loop through. So what is DP? Well, I can say DP in this case, because at the end, right? At the end, what we want to return is a total count. I say starting from the root, okay? Because the root is the index we can use, okay? We can say, okay, that's the root with the index, and we need a state, right? The current state. What is the current state? We can't just do the root itself, can we? Or you can say, if I know the total count of palindrome, of all palindrome on the left subtree, and I know the total count on the right subtree, does that work? Or maybe not the total count, but like the current state. And what do you mean by the current state? I mean, I cannot bitmask the entire path, and then I lose information of the position, right? All right. All right, I know about this. I know about this. I know about all the hints. Mask V be a mask of 26 bits, yes, represent the parity of each character in the alphabet on the path from node 0 to V. We have this idea, right? We have this idea. From this to this, it's the path, right? It's the path. Unless I read the question wrong. No, I didn't read the question, because you can... Wait, hold on. Do we have to go through 0? Is represented by where is the parent node? Okay. The number of pairs of nodes such that this and the character assigned to the edge on the path from U to V can be rearranged. Okay, the path from U to V, does it go through the root? We'll find out. If it goes through the root, then the problem becomes like much easier. But I was thinking it doesn't go through the root, like a 314 will work. Okay, so that is okay. So let's just take a look at this. All I need to do is change this one to A. Okay, so if I change this one to A, it's gonna cost a lot more. Let's change this one to B. Okay, so the 1, 3. So 0, 1, 2, 3. This one, I change this one to B. If I change this one to B, which means what I have is going to be this one's a B, right? So the total palindrome, I think, is going to be, so 1, 2, 3, 4, 5. So we have 5 basic one plus a 314, right? We have a 314, and we have, 105, 1025. So we can do a 1025 CAC, and that is it. So I think it shall give me 7. Does this one give me 7? 7 or 6? That will be determining. It gave me 7, so this one does include. This one does include. Okay, I wanted the definitive answer. Give me a definitive answer by changing this one into an irrelevant number. Right, we do an E here. So now this should give me 6. Yep, so it does. So how does this one work? From 0 to V. Now I can do from 0 to everything. Right? So from 0 to 3. So I have, okay, from 0 to 3. is going to be CB. From 0 to 4 is going to be CB. Right, from 0 to 5 is going to be AE. 0 to 1 is C. And 0 to 2 is A. So given this, how do I identify the palindrome? Like, can I go from 1, right? Because I can also go from 1. I'm gonna stop right here. It needs more time. I need more time on this one. I feel I have the idea. I mean, I have I have all the idea that the hints have, but I just need to tie them together. All right, I'll end it right here. We'll keep digging on this tomorrow. All right, I'll see you guys tomorrow. Adios.